recording, we will see how we can use ADK's base memory service, which ADK has provided as an abstract, a class memory class abstraction to um, use it to extend it to actual implementation of the memory objects, right, or the memory service. So as part of the package, ADK provides a in-memory service implementation and the Vertex AI memory bank service implementation. It also provides an implementation of a memory service using Vertex AI RAG memory service, right? Or Vertex AI RAG. But let's say I need to build my own memory. Let's say I need to build my own semantic memory using Pinecone, right? I use Pinecone to store the semantic memory. How do I do that, right? So the way we do that is we extend this base memory service, and that is what we'll see now. But let's understand what the base memory service within ADK is, right? So if you go to the ADK GitHub code, which Google has published as an open source, under source Google ADK, you will see the memory folder within that base memory service. The base memory service exposes, so if I go here, so it exposes two functions, add session to memory, right, and search memory. So when I'll extend this to create my own custom memory, I will put my the logic that I want to use to store things into memory or memory items into memory. This is where I'll code it, and when I need to search the memory, this is where I'll code it, right? And yeah, and these are other class abstraction that ADK has provided, right? But now let's see how, if I have to create my own Pinecone based semantic memory, how do I extend this base memory service and code it, right? So if I go here, right? So, okay, so this is where I coded the Pinecone memory.py, right? Before that, like I created a trial or a free subscription in Pinecone. But let's look at this code, right? So here you see Pinecone semantic memory services. This is the class which will implement my memory service, and I have extended. I'm actually inheriting from the base memory service class that we just saw, right? And then, so I'll skip the init part. In the init part, I'm just taking what I need, like to connect to Pinecone, the index name, the embedding model that I'll do to embed the question, so that next time I do a semantic search based on the question, right? So the init part, let me skip that. Ensure index exists also I'll skip, because here I said, like, while creating the memory with an index, if the index is not there, create the Pinecone index. Generate embedding also I'll skip. This is a utility class or utility function that I created, so that Pinecone memory, this class can like use this to embed the input that it gets, right? Extract QA pairs is a utility that I created here, where so you remember in the base memory service, we had this add session to memory, right? In add session to memory, we pass the session, right? So you'll see in the add session to memory, I will call this extract QA pairs. Actually, let me go to add session to memory and it'll come back here, right? So if I go to add session to memory, so this is where, as part of the conversation, right after the conversation is done, I'm passing the session content to the add session to memory. And then with the session content, I'm calling the extract QA pairs, right? So this part has the logic which extracts the Q&A pairs, right? What was the question asked? What was the answer asked, right? This is that logic, right? Where I say, okay, if the role is user, right, then it's a question. If the role is other than user, that's a answer, right? So I finally create a QA pair, right? And that is what I returned here. Now, then what I do is, for the user content or for the answer and the question, right? The user content is the question, assistant content is the answer. I create the input text, which is a question text, answer text. Then I generate embedding for the input text, right? Because, okay, I need to generate embedding for the input text of the question, so that next time when a similar question comes, I can match with it. I don't need to embed answer text, but I need to store the answer text as a metadata connecting to this embedding, right? So here, here I'm creating a unique session ID, right, so that I can store it into Vertex AI, in Pinecone. The metadata I'm creating, what was the app name, what was the user ID, session ID, the input, I'm putting the question also and the answer also, right, who authored it, timestamp. This goes as a metadata in that row, in that Pinecone index row. This is the column of the row, and the embedding of the question is another column in that row, right? So this is how I have overwritten or implemented the add session to memory, right, to create my own custom logic to store the Q&A pair as a semantic question. The question I embed it, and the rest of the things I put as a metadata, and then upsert into Pinecone, right? So that is the load part of the memory, right? And we'll see how we use it in the agent. In the search memory, if you see, there were two functions, right? Search memory. So we just spoke about the add session to memory. Now the search memory. The search memory response again. The query that I get, I embed the query, then do a index search, right? Do a search with that query. Top K, at the top I said 5, right? Extract the memories, right? And for match in this result, right? For the number of records that I get back, I capture the metadata. From the metadata, I get the answer text, right, for that question, and create a memory entry, right? And this memory entry is, I pass it into the list, memories list, and this is what I return as search memory response, right? So because if you'll see, the search memory, it needs to return its search memory response, and the search memory response is nothing but a list of memory entry, and a memory entry is nothing but the content, custom metadata, ID, author, timestamp, right? So this is what I am doing. This is all that I have to do to create my custom Pinecone memory. Now, how do I use it? So if I go to agent.py, like this is where I'll use this memory. Okay, so here let me start with the main part, right? So scoping is very important, right? So your memory should be scoped. Your session also should be scoped. So in my case, my scope is the app name, which is, I said, Pinecone demo, and a demo user, right? This is scope, right? Everything that I store, all the memories and the sessions, will be part of this namespace or scope, right? And then this is where I create the memory service. I say, like, for this agent, I'll use my Pinecone semantic memory service. And for session, I'm not worrying about session right now. It's an in-memory session service, right? I am not going to store it or persist it in memory session service. Then when I create the runner, right? Runner is the actual piece of code that will run the agent, right, where I give the name of the app, the agent name, right? So agent is, so demo agent is where I have created, so the demo agent is available here, where what I'm saying is, yeah, this is the demo agent, right? Agent, I'm saying, okay, it will use Gemini Flash 001. Name of the agent is memory demo agent. Agent demonstrating Pinecone semantic memory. You are a helpful assistant with access to semantic memory. When asked question, use the load memory tool to search for relevant information from past conversation. The memory is semantic, so you can find answers even if the question is phrased differently than the original, right? And I've given it the load memory tool. The load memory tool is a built-in function within Google ADK. ADK provides you the load memory tool, and when you say that my memory service is this, when I say that my memory service is this, load memory tool knows how to use this to now search and load the memory, right? So if you actually go into the load memory tool, you will see that it actually, so if I go here and if I go to the process LLM request load, so there is a place where, okay, it is in the load memory tool calls, where it is like it's this one, right? It's parent class. If you see in the parent class of the load memory, it calls the from the invocation content. Where is that? Load memory tool. If I go to the init, okay, I'm trying to find the init. Okay, this is the init. If I go here, tool context dot search memory response and the tool context, right? Okay, I think it was here, tool context. Let me go to the tool context. Yeah, so this is the invocation context. Let me come back. I wanted to show that from the invocation context, it actually gets the okay, process LLM request from config. Where is the invocation context? Okay, not this one. Let me go back. Process LLM request, get declaration self.init. Okay. In the parent init, it will have the invocation. The memory service, it knows from the invocation part. I'm trying to find that memory service. Memory service not here. Let me go back. Not here. I saw that somewhere. Tool context dot search memory. Tool context. Okay, load memory. This is where, okay, so this is the place. The invocation context, right, has the memory service, right? You remember we'll say memory service equal to Pinecone memory service. This is that extension of that Pinecone memory service. It does that search, right? So this is how, like, this load memory tool knows how to call the memory service that I have mentioned, I have configured for this agent, right? So this is where I configured saying that use the Pinecone memory service, right? Now in the runner, I'm saying what is my agent name, what is my session service. My session service is in memory session service, and the memory service is the memory service, right? Then I'm running it. So I'm now sending the message. I'm sending the runner instance, right? And I'm sending it this information which it will store in the memory. You remember, like in the pinecone session, in the pinecone memory, add to session, when I pass this context, right, add to session, let me go back, add to session, add session to memory, this session content comes, right. So when I execute it, right, the output of this goes there, it does the Q&A pair, creates the Q&A and stores into the memory, right, it stores into the memory. And then once it is done storing the memory, I again, so this is where I'm adding the session to the memory so that it gets loaded in the memory. Now the retrieval part, right? Once it is stored, how do I retrieve it? I create a new session for the retrieval part using the same scope, right? Because all my memory in the memory store is stored with this scope, right? Then when I ask a question, what's my name, which I already put in the memory before, because I said, hello, my name is John Smith, I work as a data scientist, my favorite programming language is Python, I like playing basketball on weekends, right? This is already in memory. So in the retrieval part, when I ask a similar question, when I will say, what's my name, and send the message to the runner, it retrieves the memory and can give my name now. Now it's a separate session. If you see, if I've created a new retrieval session, so it still knows what my name is because it has stored my name in the previous session. When I say what is my occupation, it can tell my occupation also, right? So these are some of the test questions that I have created to demonstrate this. And then this is the conversation too, where I'm adding more memories, where I'm saying I'm graduated from Stanford University, my favorite food is sushi, I live in San Francisco, right? So these are additional memories I'm storing. And then when I'm asking again, where did I study, it should be able to tell me that I studied in Stanford, right? We'll run this program now, but before that I wanted to show you that our pinecone index now is empty, right? So pinecone is what I'm using as a memory store now, right? So if I now run this agent.py, it will start sending my info, and then, yeah, these are the conversation happening, right? This is the QA pair, right? This is the first session, second session, fourth, sixth, right? These QA patterns are getting extracted, right? And stored in the memory, answers stored in the memory. So let's see how the memory is stored now. So this is my memory is created now. So I have 1, 2, 3, 4, 5, 6 memories. 5 memories, right? Yeah. So the first memory is my name is John Smith. So that is, it just stored this question answer pair, but I work as a data scientist, right? That it stored. I love playing basketball on weekends, right? It has stored all these things, right? And now when I ask the question, what's my name, it calls the load memory tool, and it knows that my name is John Smith. I work as a data scientist. Like when I say what is my occupation, this is already stored in the memory, right? It does that semantic match, right? And then gives me the answer, right? This is how we can create a custom memory by extending the base memory service of ADK. That's all for today. Thank you.